Welcome to Deliver Reliable Precision Parts Faster with Blacksmith. Thank you for joining us today to explore how your Markforged X printers can deliver reliable precision parts faster with Blacksmith software. In today's webinar, you will learn about which additive parts require inspection. What are the advantages of digital in-process inspection? Who are some of the organizations that are currently benefiting from Blacksmith? You'll see a demo to learn how Blacksmith works, and we will share how to best evaluate Blacksmith. We will have time at the end for questions, but feel free to post your questions in the chat. We have three members of the Markforged team here today. And Ted, would you introduce yourself, please?
Yeah, hey everybody. Glad to spend some time with you this morning or afternoon, depending on where you are. I'm Ted Plummer. I'm the Director of Product Management for Markforged. I've been here for 3 years and spent a lot of my time thinking about Blacksmith. So happy to talk with you all.
Great, thanks, Ted. My name is Mark Levitt. I'm Senior Product Marketing Manager for Software and Security here at the company. Been here a little over a year. Look forward to engaging with all of you.
Hi everyone, my name is Keith Ozar. I'm the Principal Customer Marketing Manager at Markforged. I'm a recent hire. I've been here about 4 months.
Thank you. So you all know firsthand the power of 3D printers to produce a very wide range of parts. Most of you are involved with producing tools, including jigs and fixtures, that are used in manufacturing or processing end-use parts or products. And some of you, an increasing number, produce end-use parts directly on your 3D printers. When your tooling or end-use parts are used in a regulated industry to help create automotive, aerospace, medical, oil and gas, or renewable energy equipment, or to produce or package food or chemicals, you or your customer need to comply with the health, safety, and other regulations. Having the ability to validate and document that your parts were printed with the necessary accuracy and process is on you or your customers to demonstrate that compliance and traceability. For traditionally machined or molded parts, you likely have a formal process that involves internal or third-party manual inspection and testing. For 3D printed parts, you either use the same process if you can, or skip the process entirely, because that would add cost and time, whose savings is why you chose to 3D print those parts to begin with. Not having an efficient process may be keeping you and others in your organization from replacing tooling or end-use parts with higher dimensional accuracy requirements.
There's, like Mark said, there's tons of different methods for validating that the thing you made is the thing that you wanted to make. And a lot of that depends on the criticality and the use case of the part that you're actually manufacturing or the process that you're going into. In 3D printing, we talked to a lot of customers, and visual inspection, pull it off the print bed, it looks good enough, let's put it in there, see what happens, is kind of the norm, we'll say, especially for FDM 3D printing. If it's a part going off to a customer or a part that has to interface with some kind of critical tolerance, you'll see some calipers coming in. And then more rarely, but especially in like the aerospace or rail industries, we're seeing people get into dedicated inspection processes where this part's coming off of the printer and going through your QA, your metrology, your QC team. All of this is going to depend on what you're doing, the value of the part, the criticality of the part. But each of these different methods has its own challenges, right? Visual inspection is maybe the cheapest and easiest thing you could ever possibly do, but it's going to have high variability person to person, machine to machine, and it's going to have low traceability. Full CMM inspection with a multi-$100,000 laser scanner is going to give you the most precise results you can get, but it's an expensive capital expenditure in equipment. It's expensive for humans to run the equipment, to set it up, to make the reports. And so you have to make sure the value's right there. All the way to the right, in-process inspection is what we've been looking to bring to the market with Blacksmith, specifically on the X7 with the built-in laser micrometer. We've developed a process that allows this to happen automatically in the background. So all you have to do is enable it, and we'll go through a demo of how that works. And so the idea is that with minimal time investment, you're going to get consistent, reliable results across all of your printers, across all of your operators, right off the print bed. So you're not just printing parts, not extruding plastic, but printing known good parts. And the goal here is to accelerate time to market. How can you get these parts from your printer into operations faster with high confidence? I've talked to a number of customers in the aerospace where they're printing parts, then they have to be taken from the printer to the CMM, and then the QA department might have a backlog of up to 3 weeks. And so you've taken a part where the benefit of additive is that you can be agile, you can be responsive, you can be fast, and you completely lose the speed advantage because now you have to go through a process that could take weeks. Once that part's validated, it goes off. Where we have seen a great number of customers be very successful, and Mark has some really interesting videos from those customers kind of explain their processes here in a minute, is where they've been able to qualify a certain set of parts, including flight components for FAA certified parts, and say, you know, Blacksmith is giving us the reliability, it's giving us the precision that we need to know that this part is going to meet our requirements. We can take it right off the printer and put it right into operations. And one customer told me, like, you know, the helicopters are flying faster because of this, which is really exciting for me to see that that benefit and that technology helps solve a real pain point for a lot of manufacturers. And so that's what we talk about Blacksmith as the autopilot for digital manufacturing. It's taking your part design, your production, and bringing it together with a full end-to-end AI that knows everything about the material that you're using. We've qualified the properties of material, the printer, and the software. We can do compensation calibration and a lot of under the hood ML to do things like fiber placement verification, non-destructive testing, and give you the confidence that what you've made is going to meet your requirements. And that's really the crux of what Blacksmith is all about.
I'm going to show you 2 short excerpts from YouTube videos that we created over the past 6 months. First one is with Hangar One. As you might know, Hangar One is a avionics maintenance and repair installation service provider with customers in airborne law enforcement, business aviation, and general aviation based in San Diego. Hangar One's been using Blacksmith for digital part inspection of aircraft parts because it's faster, easier, and more reliable than the prior manual inspection process. And I'll play that clip in a moment. The second clip you'll see is of Vestas. Vestas is a global leader in wind energy design, manufacturing, installation, and service of wind turbines across the globe. And Vestas has been using Blacksmith to scan and certify each part to ensure tolerances and part accuracy, which eliminates the cost, lead time, and hassle of third-party certifiers. So I'm going to switch gears here, stop sharing of this slide deck, and I will share the screen that shows those videos. Wait 1 minute, please.
This is just an adapter plate we're using for mounting a modem for a customer. And so here we have our inspection. So we want to take a measurement, say, between this bore here and this bore here. And we know the distance between here is 112.49 millimeters. This is just because we don't work in metric in our shop, but so I know what it's supposed to be. It's supposed to be 4.428. It comes in at 4.429, and I am way within the tolerance range that I need to have for that dimension right there. Every part that needs to be inspected, we will generate the inspection report at the end. Right. And the inspection report down here gives me the measurement. So for measurement 1, here is what the nominal value is. Here is what was measured. You know, here's what your deviation was, and it'll give me all of this. And this whole report that we have, this goes along with our inspection reports. It goes along with our set of prints. We package it up all nicely, and it either gets scanned in and goes on gets attached to the part digitally in our system, or if need be, we will print it all out and we will give it to a customer if we're printing something for a customer part. Once they understood what it was that we were doing and how this works, all of our ODAs, DERs, and actually, you know, the people we deal with the FAA, we're all like, oh, there's no difference between this and using, you know, if you were using a laser scanner CMM or a probe style CMM, it does the exact same thing. It's just, this is new, so they don't know about it yet. They don't understand it yet. And once you talk to them about it, then everybody's been really, really open and really accepting of what it is that we're doing here. Especially when it's, you know, we're able to document everything, which is a big thing, is always document things.
Great, thank you. That was Matthew Roth of Hangar One. Matthew Roth was talking about how he tested the Blacksmith measurements by using his traditional measurement process and found that the results were exceeded what the prior measurements were. So it was very confident about that. And now we're going to share the screen for the Vestas excerpt.
So this is one half of a tool that's called the TC marking tool, or top center marking tool. With Markforged, the Blacksmith system, with the spirit of DDM, we can manufacture, calibrate, and generate a calibration report, all in the time that it takes to manufacture the part. It used to take 3 weeks at around $4,800 to manufacture. And we were able to design and manufacture in 3 days for just under $100. It releases us from being reliant on outside manufacturers. It democratizes and opens up new avenues. It is a game changer.
Great, thank you. And I'll hand off to Ted before we come up.
Great. I love that Vestas video. Got to hang out with Jeremy a little bit a couple weeks ago in Chicago, or Detroit, sorry. And they're doing some really cool things. You guys see my Blacksmith screen? Or
Yep.
EIGER? Cool. All right. Let's see. I don't have the list of attendees up, and even if I did, I don't know all of you yet personally. So I'm hoping everyone's used EIGER and is familiar kind of with this view of it. Ignore that Smart Slice FEA button. You know, hint, hint. Down the road, we're going to do some cool stuff with this acquisition of a company called Teton that we just made a few months ago. We're working on that. I just realized that's there. No worries. If you haven't used Blacksmith before, you're not familiar with it. I have a bunch of tabs open here to save us waiting on load times, but turning Blacksmith on is really as simple as like enabling Blacksmith. There, we're done. Hit print. From there, you can go in, you have your classic layer editor. You can come in here and make sure that your design is going to be right. Your supports are all in the right place. Another hint, support overrides coming any day now. So look forward to playing with that in EIGER for everybody. But you can come in here and make sure that's all correct and your part's ready to go. And there's a new configure Blacksmith button. So what does that mean? When you configure Blacksmith, we want to give you the power to tell us what your critical dimensions are and make sure we give the right amount of scan resolution to those dimensions so we can give you high reliable, high precision results, and then tune down the scan resolution for the rest of the parts so we optimize for throughput. And so by that simply, you can come in here. Blacksmith will use machine learning to detect all of the features of your part, and you can start to create surface groups. And so I could say the surface group 3, these the radii of these cylinders is critical because it's going to mate with something. I save it, I hit finish editing. I can make as many of these surface groups with as much varying resolution as I need. There's a little tooltip up here that'll tell you how big of a critical feature. So critical feature meaning in this case of a cylinder, the radius. As long as the radius is greater than 3 millimeters, I'm going to get plus or minus 30 micron of precision with a medium setting. At the high setting, it goes to 1.5 millimeters. At the low setting, you're looking at anything 6 millimeters. So you can really tune to get the right density for your part and save you throughput time. With this settings here, hit save. We'll do low everywhere except for the groups where I've indicated high, medium, and high. It's going to go through the normal slicing process. What this is doing is generating, using our understanding of the part and the process to generate a tool path for the laser. So you'll see it when you print. It'll print, scan, scan, print, scan. The internet's going to be slow because we're doing a live demo, and I'm working out of a basement today, so bear with me on that. But you don't have to worry about the toolpath. You don't have to worry about fixturing or setting up the inspection process itself. The printer is going to or the slicer is going to figure all of that out for you, give the printer the instruction set, and then you'll be able to see here, generally what we're looking at is on the order of 2 to 5 or maybe 8% increase in print time to get those high resolution scan results. So on an 18-hour print, I'm going to add about a half hour of scan time. And it's very variable depending on the complexity of your geometry and the types of settings you choose here. We'll let that run, and it's going to finish now. As soon as I say we'll move on, it'll finish. And let's see what the updated time is. Okay, cool. So by reducing the part scan resolution globally, in selecting just my critical features in these groups, I've cut that scan time from 32 minutes, I think it was, to 14 minutes. And so you can come in here and play with this and really customize your manufacturing process to get the right throughput. From here, you simply hit print. Your printer's been calibrated. We didn't talk a lot about that, but Blacksmith comes with a robust calibration procedure that involves a reference tool that you put into your printer, and it runs an automated process. It'll scan this reference tool, which is a highly precise machined piece of aluminum. Each one is serialized. Each one is inspected with a CMM. So we have a good reference for that bed, and that data is uploaded to EIGER. So your printer will be calibrated to the reference bed you use. This will basically, as close as we can get within physics, eliminate printer to printer variability. So you're going to get the same parts off different printers all over the world, which is really exciting. And it's going to allow us to get this kind of precise measurement with the laser micrometer. That process is great. It runs you run about once a year, or anytime you move the printer, do any major maintenance. It runs cold, it runs hot, it runs cold. So it accounts for like thermal effects of the printer as it heats and cools. It's very cool to sit and watch if you have a few hours to kill. Here I printed these a while ago here in my basement lab, but you can see I got 3 parts, 3 scan reports, and it shows me here the point cloud of the parts. We can go ahead and pick one that we want to inspect in detail. Blacksmith loads the point cloud, so you can see like, oh, where was it measuring? Where's the difference in density? And you can I guess it's kind of hard to see density differences here because I think I just use a global setting on this one because I'm a bad presenter. I can switch from point cloud to something maybe a little more useful or more familiar as a heat map. And down here on this histogram, I can indicate my global tolerance for the part. So let's say I'm making this part and I have a plus or minus 75 micron tolerance. I can see that 10.5% of the points are going to be under that tolerance, and 5.6% of the points that we gathered are over that tolerance. And then I can very simply kind of, zip around the part and see like, there's maybe some under extrusion or some like free hanging supports here on this one, but the other ones are all the other members here are all in spec. Some of the support interfaces where you would expect to see some kind of lower precision where there's supports, you can see that, and you can get a quick visual feel of how good is my part. And again, this is 75 micron of inspection on a machine that I believe is the spec sheet calls for like 125 micron of precision. So we're scanning it. We're being very brutal so that how good your parts are. Blacksmith, I mentioned earlier, does AI feature recognition. So we can come in here and select different features and learn things about them specifically. So for that cylinder, I can see how many scan points I gathered, what its surface area is, different deviations, more important measurements like the radius. So this was supposed to be a 2.54 millimeter radius. It's out by 0.04. And then based on my tolerance as the manufacturer, I can assess, is this good or is this bad? I can also add, or like the centerline angle of the cylinder is important, right? If it's going to mate or be a screw hole or have some kind of mounting, that's important. I can add that to my report. And my report is this list of saved measurements over here. And what that allows me to do is come in here once, configure all the critical measurements that I want, whether that be radii, whether that be distance between holes, whether that be distance between planes or angularity between surfaces. Have an angularity, dihedral angle between those two surfaces, whatever your GD&T style measurement is, you add all these up over here. Once you do that once, every single time you print the part, it's going to remember and it's going to generate inspection reports for you. So now that I've added that measurement, we can go ahead and generate a scan report. It's as simple as pressing a button. We also have an API, so you could connect this into a quality management system or a PLM system where you want to get feedback. You could automate the feedback so that this report gets generated every time you hit the print button and automatically sent to a customer in an email, automatically logged, or just kept in EIGER for you to have it. And this will have a lot of information about the part, the type of infill, who printed it, in any inspection notes you can see I QA passed it. It gives you a quick overview of the scan data, the histogram here, and information about the data that was collected, process control data about unique identifiers for the device. What reference bed did I use? When was the machine calibrated? And there's a notes field here where on the other page you can add whatever notes you have on that specific instance of the part. And then these views are all automatically generated. The system will understand the features of interest for you and will orient this part so that you have this nice view. This is also printable in black and white, this zebra striping. So if you don't print it in color, you can still see the difference in tolerance, which is great. And then for every measurement that I added, it will generate a view for that specific measurement, and you can QA pass or fail each component. And so you're getting a really rich quality report out of the system every time you hit the print button. All you have to do is set it up the once. Yeah, and then really quickly, this is our API documentation. And if you wanted to get a parts printed scan report and send it off, you can give this to your IT friends and they can write there's examples in here of how to do that. It's very, very easy. So yeah, that's kind of end-to-end Blacksmith, where you go from part to scan report.
Ted, was there fiber reinforcement in this part?
This part didn't have fiber, but we do have fiber reinforcement verification. So one of the things when you're configuring Blacksmith that I kind of glanced over here is you can do verify fiber. And so what fiber verification does is generates a machine learning model of basically a binary classification model. There is fiber or there is not fiber throughout the entirety of the part. And so if you're making strong parts, overhead lifting applications or anything where strength is absolutely critical, we can do in-process non-destructive testing essentially. So we're scanning the fibers as we're laying them down, and you'll get confirmation that the fiber is actually in the part. There are ways to through user error inject not fiber into a printer, and there can be there are ways to kind of have that error. So this gives you the confidence that this part not only looks good, is dimensionally accurate, but is going to have the strength that you require without having to buy a CT scanner or an X-ray or chop it in half and look inside. So we're really excited about that and other ideas that we have for bringing more of that inside view of the part to you.
I bet some of the users might have had a print job that ended because of lack of material or some other issue.
Mm-hmm.
How does Blacksmith identify those kinds of problems?
Yeah, great question. Blacksmith runs now at the edge a machine learning model for print failure detection. And so while we're collecting the scan points, we can actually look and compare what we expect to see, right? So we know what the part should look like. We can compare our measurements over a few scans. And if you, for one example, had a rat's nest spaghetti monster kind of thing going on, there's a bunch of sensors in the system that catch it normally, but this is absolute. So if the part's not where we expect it to be, if the part's not within a certain tolerance, we can notify you and you can abandon, restart, or continue your print. Yep.
So for those of you who want to evaluate Blacksmith for your X7 printers, we recommend that you identify either one or more parts that you aren't printing today because you feel like you can't, because you don't have a reliable, efficient process for parts that because of the specific tolerance and traceability requirements of those parts. Maybe there are parts that you're still machining that you haven't yet moved over to 3D printing because the folks who need those parts aren't familiar enough with 3D and don't have the confidence, 3D printing, and don't have the confidence about the process for tolerance and traceability. We recommend you work with a partner, and the partner can help you print the part and generate inspection reports with Blacksmith, either on their printers that may be enabled for Blacksmith and calibrated with the reference bed, or potentially do that for you as part of an evaluation. Then we encourage you to compare Blacksmith's inspection report to see how accurate it is compared to your traditional processes. And we're confident, based on what we've heard from Hangar One and many other customers, that Blacksmith is a highly accurate inspection process. And lastly, in this year, 2022, we are running a promotion 50% off of the suggested retail price or manufacturer's list retail price for Blacksmith, as well as for EIGER Fleet. So you can get your first year subscription to Blacksmith at 50% off. We've also introduced some volume pricing. So if you have more than 5 X7 printers and you want to enable all of them, there's savings there as well, along with 3 and 5 year subscriptions savings. So now is a great time to evaluate and consider purchasing a subscription to Blacksmith for your X7s.
Yep. And Tom jumped in with a question. It is available for existing X7s. We'll send you the calibration bed. You can do it yourself or work with your VAR to get it done.
Right. And if you have purchased Blacksmith in the past and you're interested in adding Blacksmith to additional X7s, you can also take advantage of that promotional offer. So as you know, our slogan is we're reinventing manufacturing today, so you can build anything you imagine tomorrow, through over-the-air updates, through regular, sometimes daily, but weekly and monthly updates to EIGER as well as to Blacksmith. We are constantly delivering improvements and new capabilities. If you looked at Blacksmith a year ago, a little bit more than a year ago at launch, and then compare it to what it is today, it's very, very different. Has a lot more capabilities, and we look forward to having more of you look at and evaluate Blacksmith. Again, not necessarily for the parts that you're currently printing, especially if they're tooling, but for parts that you could be printing, either a tooling or end-use parts. And let's see what other questions we might have here.
Question on cost for you, Mark. How much is the subscription?
So the list price is $10,000 a year for Blacksmith. Again, there are savings if 15% off for a 3-year subscription, 20% for a 5-year subscription. And again, in the year 2022, the price would be 50% off of whatever that best price is. So if you already get 20% off a 5-year subscription, you would then take another 50% on top of that. So the price is definitely better than it's ever been, and we look forward to having more folks evaluate and purchase it. We also want your feedback. A lot of the functionality that Ted and his team have added to Blacksmith are the direct result of customers who have been using it for 6, 9, 12 months or longer. And so we definitely want to hear how we can best make the Blacksmith inspection software as valuable to you as possible. And is that a per seat? So the question is, that is a per printer. So if you can choose to enable Blacksmith on one of your X7s or multiple X7s, that's up to you. If the reference bed itself, you can use for multiple X7s. And so that reference bed typically would be something that you would either purchase or potentially have your partner calibrate for you and potentially provide some kind of evaluation or trial for that. So that's where we are. Another question.
Yeah, I can jump in on this
Please.
Anonymous question. The short answer here is Markforged is not planning on moving to an open source slicer. We've developed our own slicer, which solves a number of our unique needs, right? The ability to reinforce fibers reliably with high precision. Also, the ability to support our fleet of printers. There's a number of advantages, and actually accelerate. Our slicer allows us to accelerate development rather than going through an open source kind of standard off the shelf model. I will say we just introduced PLA for low part cost printing options. And so if you're looking for a prototype material or something lower cost, you can go to PLA, which is available now for our printers.
Right. We did refresh our Blacksmith webpage, so the latest information and messaging about Blacksmith is on that page, along in addition to being in the new one pager. So definitely visit markforged.com/Blacksmith to see the latest information. And again, reach out to us or to one of your partners to have a conversation about Blacksmith to see if it would enable you to expand 3D printing in your organization, potentially to teams that aren't currently taking advantage of that. And we look forward to working with you doing that. Very good. Well, we will be following up with you with a link to this recording and answer any questions you might have. So have a great day, everyone, and thank you for joining us.